Folks, it's Mr. Gustin back in the chemistry classroom. Today, we are going to review the ionic charges that exist on the elements in the periodic table, and then we are going to talk about those in the context of writing simple ionic formulas. Okay? So if we go back to our periodic table unit way back when, or in our atomic structure unit, we remember that the first column, elements live in the first column because they have one valence electron, which means when they react to form ionic compounds, they will be giving up only one valence electron to achieve their octet or duet. That leaves them with a +1 overall charge. They have one extra proton compared to their electron. We're left with a +1 charge. Family number 2, the beryllium family, has 2 valence electrons, which means when it forms an ionic compound, it will give up 2 valence electrons, leaving it with a +2 charge. Then we run into this mess of elements down here, known as the transition metals. I don't know. The transition metals have any number of ionic states. They could be +2, they could be +3. We have to examine these more closely, and we'll do so later. But there's a certain type of name associated with the transition metals that helps us understand their ionic charges, and it's actually pretty straightforward. As we come all the way across over here to the boron family, the family over here, aluminum, gallium, they will form +3 charges. They have 3 valence electrons. In order to achieve 8 or 2, it's easier for them to lose 3 electrons. When they lose 3 electrons, we're left with a +3 charge. Carbon's the weird one. Carbon, we say it's ±4, but like holy smokes, I don't think carbon's going to form an ionic compound whatsoever. It's going to stick with bonding with some nonmetals covalently, and we haven't covered that yet. So I wouldn't worry too much about the carbon family and its ability to form ionic compounds. But these elements down here towards the bottom of this family, well, really just these two, lead and tin, these elements act like metals. They're big. They act like metals. They lose their electrons. Check the transition metals for tin and lead. Then we get over to the nitrogen family. They have 5 valence electrons, so it's easier for them to gain 3 to give themselves an overall net -3 charge as they form an ion. And we can just continue that pattern all the way across our periodic table with the understanding that the noble gases don't react very well. And if they do, they certainly don't do it ionically, so they have no ionic charge. Here is our pattern of ionic charges. We are aware of this now. Now, I would need to use this, or I can use this, to solve a couple of examples of names for ionic compounds. So, I'm going to go ahead and write out a few examples here of elements, or of compounds, ionic compounds, that we can test out our little scheme with. Okay, so we have sodium chloride. We'll try calcium, calcium bromide, and we'll try aluminum oxide. We'll do aluminum aluminum fluoride. No, oxide. That's what I want to do. Okay, so here we go. I have these chemicals laid out here for me. These are the names I've been given. Someone says, what is sodium chloride? You need to come up with the chemical formula for it. Well, the first thing I'm going to do, because they are ionic compounds, what I'm going to do is find the ions of the associated elements here. So sodium, I go out and I find sodium on the periodic table. I know it's a +1 charge. I'm going to write out sodium as a +1 charge. Na+1. I know that when it forms an ionic compound, it's going to end up as Na+1. The next thing I'm going to do is go find chlorine, chloride ion. Right there. There's chlorine. It's a -1 charge. So I look at my my cation and my anion, my positive and negative ions, and I say, okay, with the understanding that ionic compounds need to have overall neutral charges, how many sodiums will I need to balance out the chlorine's charge? Well, sodium's +1, chlorine's -1. I guess I just need one sodium and one chlorine to make an overall neutral charge. You bet. There's my chemical formula, NaCl. One sodium, one chlorine, net neutral. Let's try another one. Calcium bromide. Let's follow the steps. Where's calcium? There's calcium. It's a +2 charge. Calcium, Ca +2. Bromine, where's bromine? Right below chlorine. Found it, element 35. It's got a -1 charge, Br -1. Ask myself the question again. How many calciums will I need to balance out bromine? How many bromines will I need to balance out the calcium? Well, calcium's +2, bromine's -1. I'm going to need 2 bromines to balance out the 1 calcium. 2 bromines, Ca, Br, itty bitty 2. Calcium with 2 bromines, that's calcium bromide's formula. Bam! It's getting pretty easy. I see a pattern. How about aluminum oxide? Let's go do our thing again. Let's go find aluminum. Where's aluminum? Right there. Found it. Where's oxygen? There it is. Found it. Aluminum is a +3 charge. Al +3. Oxygen is a -2 charge. Ask myself, how many aluminums or oxygens will I need to balance each other out? This one's a little more complicated. I need a little bit more math. Well, right now, aluminum is winning. Right now, the positive charge, there's more of that. So I'm going to go ahead and add a second oxygen. Let's imagine maybe it's AlO2. I don't know. If I add a second oxygen to this group, now I've got a total -4, only +3. Well, I might need 2 aluminums then to balance that out. Now I've got +6, -4. Oh, wait. If I add a third. Oh, I see it. Do you see it? Al +3, O -2. If I have 2 aluminums and I have 3 oxygens, that balances it out. Now I'm good. Did you see how I used my little model? I added an oxygen, and then I added an aluminum, and I added an oxygen again, just to kind of organize my thoughts until I was able to say, nope, got it. And then I went ahead and wrote Al2O3. You can do the exact same thing. Some people like to do it all in their head. Nah, write it out on paper, on your whiteboard, do it yourself, figure it out that way. There we go. These are the basic ionic compounds that we can write. I want to try something else, though. I want to go ahead and try and look at some transition metals. Check it out. Let's try iron. Two oxide. Let's try copper. 2 chloride. And let's try lead. 4 oxide. Let's just try these chemicals and see what happens. Immediately, when I see these, I can go ahead and try the same thing I've been doing before. Let's go try the same thing. So, first chemical, iron oxide. All right, I'm going to go find iron on the periodic table and hope I can find its charge. Where's iron? There's iron right there. Whoop, element 26, iron. Is it +1? No, not +2. It's not +3. It's in my transition metals section of the periodic table. I need some way to figure out what its charge is. If only there was something that told me the charge. Do you see it? Do you see it? The naming scheme is different. It's not just iron oxide anymore. Now it's iron 2 oxide. The name tells me exactly the charge of iron. It tells me the charge. The Roman numeral tells me the charge. What is the charge of iron? It's +2. Only transition metals will tell you the charge. Okay? Only transition metals will tell you the charge. So iron is +2. oxygen, I can go find that one. There it is. It's -2. What's my chemical formula? FeO. The ugliest chemical compound you'll ever see. That's a Spanish joke. What's the next one? The next one is copper 2 chloride. Let's go find copper. Where's copper? Where's copper? There it is, element 29. Found it. Is it a transition metal? You bet it is. Does it tell me its charge? Right there it does. Copper 2, Cu plus 2. Where's chlorine? Right there, element 17. Cl minus. How many chlorines balance out my coppers? 2. Cu, Cl, baby 2. I'm getting the hang of this. Let's go find the next one. Lead 4 oxide. Where's lead? There's lead. Oh, okay. It says it should be +4, but also remember, lead and tin are these ones that kind of live over here. They're on this side of the stair step. Those are my transition metals still. Lead 4 oxide. So Pb, that's lead like peanut butter, +4. Oxygen is -2. Oxygen -2. How many oxygens will I need to balance out the lead? I'll just need 2. PbO2. 2 oxygens to balance out the 4 charges on my lead. There you go. This is how we name our basic ionic compounds, our binary ionic compounds. Okay? We've laid out the periodic table. We've discussed the transition metals. All of these things can be found, all these ions can be found on your ion sheet on the back side of your periodic table. You should be prepared now to look at any name of any ionic compound and write out its chemical formula. I hope this helps. See ya!